Okay guys, this is where we left off in class. I basically drew these distributions for you, but I didn't have a chance to describe them. So there is a symmetric distribution if, let's say, most of the data is in the middle. So if this was number of siblings, 0, 1, 2, 3, 4, 5, 6, and I don't remember what our class data was, most people had 3 siblings, a little less that had 4, a little less that had 5. Notice that it is symmetric, or it could be cut down the middle. Okay. A negatively skewed distribution would be where most of the data is towards the bigger numbers, and then maybe we had 1 or 2 people that had 0 or 1 sibling. So this would be, if it was a number line, think about it, positive numbers, negative numbers. Most of the data is positive, but there are 1 or 2 outliers maybe, or something far away from the rest of the data that makes it negatively skewed. And we call it skewed because later when we find average, the mode and the median would be here, but the average would get pulled down and be more like right here. We'll talk about that later. So positively skewed is the same idea, but most of the data is on the lower end with something up here that's pulling up the average on the positive end. Okay? Outliers, they're the data values that are either much larger or much smaller than the general body of data, i.e. this or this, and we'll talk about how to figure out if something's just a little big or really big in an outlier later. Okay, so that was grouped, or that was discrete quantitative data. Now we're going to group our quantitative data. So here's an example. A local kindergarten is concerned about the number of vehicles passing between 8:45 and 9 a.m. Over 30 consecutive weekdays, they recorded the data. So here are the results. So like on the first day, maybe Monday, there were 27 cars that went by, Tuesday 30, next day 17, Thursday 13, etc. So the first thing you'd want to do is go ahead and make a table, but instead of just saying 20 cars, 21 cars, 22, they're too spread out for that, so instead we're going to group it and do 0 to 9 cars, 10 to 19, 20 to 29, etc. And you may want to pause the video part way to write down everything. Okay, so 0 to 9 cars, if you look at it carefully, okay, there was a 1. And from 10 to 19, there were 5, so you'd go through and go 1, 2, 3, 4, oops, that's the one from 10 to 19. Where is my other one? Oh, 5. Okay, so I'm pretty sure you guys could do the tallies. And then the frequency is just the total of the marks. The relative frequency is the percentage. So I'm going to just clear this for you and let you see. The relative frequency, well, there was 1 in this group out of all 30, okay, consecutive weekdays. 1 car out of those days. And if you put that 1 divided by 30 in your calculator, you get 0.003. Okay, for the next group, there were 5 out of 30, which is 0.167. The next one was 10 out of 30, or 0.33. Okay, or you could write this as 1/3, whatever. It's just the fraction of the whole. So out of all the days, here, 33% of the days, the cars fell between 20 and 29 cars. Okay, and you could use this data to make something like a pie chart. Okay, and then you'd also want to make sure you added everything up and had the total. So using that, we could make a stem and leaf plot. And what's nice about a stem and leaf plot is instead of having this list of gigantic numbers, it organizes them for us. So a stem and leaf plot not only puts the numbers in order, but it makes it really easy to see. So here is going to be our tens area because everything is 10, 20, 30, 40, 50. We're not over 100 or anything like that. Okay, so how many did we have between 0 and 9? We had 1, and that was actually, let's see, 9. So that we had a 9. For the next one, if we look back at it again, we had a 15, 17, 18, and 18, right? There were 4. Oops, there was one more. What did we decide? And 16. So we write them in order, the lowest one being 15. Then we had two 16s, right? Or one 16, 15, a 16, a 17, and two 18s. And you go ahead and do that for the rest of the data. Okay, I went ahead and did that. You may want to pause and fill in your graph, but I just went through and counted up all the numbers in the specific groups and put them in my stem and leaf plot. The key thing to a stem and leaf plot, though, is you need a key. So you need to tell the reader that something like 1 and 5 equals 15. So they know that this was a tens and this was a 1. Okay. And what's also really nice about it is if you were to turn it on the side and draw little boxes, you actually have a histogram, but we'll talk about that in a minute. So speaking of histogram, here it is. Okay, I have gone ahead and already scaled it. And notice that the most count we had, or the biggest count we had, was 10. So I went up on my vertical axis up to 10. And my horizontal, I went up to 60 because we had stuff in the 50s. So this little dot right here, this and this is just kind of a guideline if you don't have graph paper. So I'll eventually erase that. But what I'm going to do is just graph. So how many did I have from 0 up to, but not including 10, or 0 to 9? I had 1. So I will just go from 0 up to 9. Okay, I'm making a bar graph, but with spaces in between. For the next one, from 10 to 19, I had 1, 2, 3, 4, 5. So I go from 10, and I'm going to delete this first. There we go. From 10 up to 19, I had 5. And I did that for the rest of the data. Okay. Key thing here is this is discrete data. There was never a day where there was 19.5 cars. So you must have spaces. Okay, so this is a column graph again, or a vertical bar chart, but it's not a histogram yet because this is discrete data. Also, we're missing labels. So this would be the number of cars. And over here would be frequency in days. And I should put a big label up here like, I don't know, cars in front of school. Okay? All right, so that's the rest of the one that you had homework on. Now let's start 7D. Okay, so we're going to do quantitative data again, so it's still the numerical stuff, but this time it's continuous, such as your guys' heights. Okay, continuous data is numerical data which has values within a continuous range. Okay, what I mean about a continuous range is kind of what we talked about in class, is if we used your heights, not everybody is 5'4", okay, but not everybody is 5'4.1. You could use a more accurate way to measure, and you could get 5'4.12, and we talked about that in class. So normally I would have you guys measure yourselves and we would make a tally chart and stuff, but I think you understand that and I'd like to give you more time in class for homework. So I'm going to skip that. Excuse me. And instead just talk about how we would graph something like this. So a histogram is a vertical column graph used to represent continuous grouped data. Okay. There must be no gaps between the columns, and the bar widths must always be, well, equal is supposed to go right here, so we're good. And then the bar heights must reflect the frequency. So pretty much it's what we did here, but without the spaces. Okay, so if we did our heights, we could say maybe we have 5 feet to 5'5". Oh, nobody's going to be quite that tall. Let's try this again. 5 feet to 5'2", 5 feet to 5'4". This would be 5'6", 5'8", 5'10". And actually, between here and here, it's 5 feet up to, but not including 5'2". So anything up to 5'1" 0.9999999 would go in here. And that's where it gets a little tricky. So let's just assume we had 3 pretty short people, okay, that were not quite 5'2". And then we had some more. Okay, something like this. This is a histogram. Again, we would need a label here, here, and here. Okay. And we'll make plenty of those, so I'm just going to give you that rough version. All right. Collating continuous data. Okay, you can group continuous data too. So that's pretty much what we did here. And the reason I did that is we could have just done one for 5 feet, 5'1", 5'2", but it almost makes sense to always collate continuous data because there's not just people that are just 5 foot, just 5'1". So my example pretty much did that for you here. Okay, but the book talks about it separately. So you can group continuous data too. Each group is called a bin or a class. IB doesn't usually use the word bin, but I prefer it. And the size of the group is called the class interval. So when I did it up here, the class interval would have been 2 inches. Okay. And that's the key thing, is that it always has to be the same. This couldn't have been 2 inches and this one was 4 inches. They have to be the same every group. Okay, so here's an example. The following data are results in grams of weighing 50 laboratory rats. So I could go ahead and group it by, say, 50 grams. So this is from 100 up to 149, from 150 to 199, 200 to 259, oops, I lied, 249, and then 250 to 299. That makes a lot of sense because they rounded the mice's weight, or the rat's weight, to the nearest gram. But there really could be one of these, like this little dude, could really weigh 241.67 grams. And so it's continuous. Oftentimes, instead of writing it this way, they'll say 100, 150, 200. Okay, and that just means, again, it's 100, including 100, up to but not including 150. So you'll see it written this way, and this way, which is confusing. I always like to think about it this way, okay? So we could go ahead and tally. If we counted the ones, let's say we have a 261, that would go here, 133, that would go here, 173, that would go here. You can go ahead and fill in the tallies, and then we would get our frequency. So I'm going to skip tallying because I'm sure all of you could count. And we end up with 10 here, 15 here, 12, and 13 for a total of 50 rats. And right here, I would like you to make a histogram based off of my example right here and bring that to class. Okay, so we're moving on to frequency distribution tables, which we've already been using. The book makes a big deal out of it, and they have lots of examples, so I thought we would just go through it. And actually, I'm going to have to stop here because my tape only goes for 15 minutes and start another part.